Hey folks, time for another Ethernaut challenge. Okay, so the challenge today is called Force. So I've taken a look at this already and I've actually deployed the contract already, so you don't have to sit and wait as that gets mined. So what do we need to do? We need to make the balance of the contract greater than 0, and as you can see from down here, there's nothing in the contract for us to call to force funds in. Now, there are 3 methods to get funds into a contract in a situation like this. So the first method is self-destruct. So if we have another smart contract call self-destruct on itself, what you can do is you can specify the address where when that self-destruct function executes, any remaining ether in that contract that's destroying itself will be sent to that other address. And you don't need a fallback function on that destination address to send the ether there. So we could create a smart contract and call self-destruct and point that address at this force contract, which is what we'll eventually do. But just quickly to cover the 2 other ways you could force ether into that contract. One is if it's a Coinbase transaction in a newly mined block. So if you were a miner and you won the proof of work competition by creating the block faster than everyone else, you can specify that contract address that you want to force ether onto is the recipient of that Coinbase transaction. And then the other way is a bit kind of slicker, well, not slicker, just a bit more subtle. What you can do is before that contract is created, if you know who's going to actually create it, so let's say I have my address in my MetaMask, so let's pretend that for whatever reason, somehow we know that this account here, 777 Bravo, is going to be the account that creates that contract. Well, if we know that, then we can actually pre-compute the new contract's address because it's deterministic. The way it's done is it takes the creator address, i.e. the 777 Bravo address I just showed you, plus the nonce of how many transactions that account has sent, or if it's a contract, the nonce of how many other contracts that's created. You SHA-3 that, or the KeyCAC256 hash algorithm, and then that will give you the destination address of the new contract. So what you can do is you can send funds to that address before the contract is created, and then when someone creates that contract, it will have ether in it. And okay, so those are our 3 methods. Let's do self-destruct then, and we'll just start some music here. Good old DRM-free music. All right, so YouTube does not mute my channel. Okay, cool. Let's close that. Just double check I'm on Robson still. Yep. Okay. So this should be fairly straightforward, I think. We're going to use the self-destruct and then do force on here. So deploy the contract, don't really need that. What I want to do is open up Remix. Let's call this force. Okay. Let's change my compiler to 18. I'm just choosing 18 because that's what their code's written in, so I just want to have the same compiler version across everything. Okay, so if I could spell pragma solidity 4.18 contract force. Okay, let's call function hackSOR. And what we'll do is we'll give it an address of the target. And then self-destruct target. And that's it, I think. We hope. Excuse me. Okay, so I just now need to compile this, deploy it, and then I can invoke this hackSOR function and send some bounce. The other thing is I'll need to pre-populate this contract as well, right? Because right now, if I were to create this contract, it would have a balance of 0 ether. What I actually need to do is give it some ether to send over, right? So why don't I just make a default function, and what I'll do is I'll send some ether to it this way. Okay. So everything compiled, static warning, don't care. So go to details. Remember, this will show us how to deploy it. Fairly straightforward. Go back in here. I'm not even using that terminal stuff because it's not really necessary right now because it's so straightforward. Here's a take a look. So this account here created this contract, right? So it's done this contract creation call. Now, what I could have done is I could have done the SHA-3 of this address plus the knots against this this address in pre-computed what address the contract I just created is going to be deployed at. So I could have done it to this address, which is probably what I should have done, but I didn't think that far ahead. Okay, so that's now deployed. So here's the contract address, right? So this is again calculated from that address and the knots against this address. Here's the knots, right? So 14 was the knots used to create this contract address. Okay, so it looks like they've actually now supporting the console.log in here, which is great. Log. No, they're not. Okay. Where was I? Okay, so force should be my contract now, right? I should go force.send transaction. And what I want to do is from player, and I want to give it some value, right? So how much am I going to give it? One way. Why is it not a... What have I done? What? Oh, sorry, I know what I'm doing. Clearly I don't know what I'm doing. It's been a few days. Send transaction. Let's get the address of this contract. It's there. Okay, value is one way. Okay, good. And then remember, you got to put the console.log, the callback function here. So let's take a look at this transaction. Twiddle our thumbs. So let's get the next step ready here. So the next step will then be calling that haxor function on force. So force.haxor. And I need to give it the address, right? So the contract that I want to be called. So here's me sending away. So not displaying. Might be able to do it faster myself. Let's try it. Okay, there's the one way that I was expecting in that contract. Still not. Okay, we'll just ignore it then. Clear that. So now I'm going to do force.haxor, and I'm going to give it the contract address, right? So contract is going to be contract address, I think is what I want. Yeah, okay. Invalid address. Why don't you like that? Oh yeah, sorry, complaining because I need to then give it the from, which is player. And then console.log, take the result back, and I shouldn't be using console log, I should be using info because log isn't going to do anything for me. Let's see what happens here. what I can do is I'll go web3.eth.getBounce. And I'm going to give it the contract.address, console.info. So there's a one way now on this contract force. Cool. Submit. Come on. All right, well, why don't we take a look, see what's next while we're waiting. I probably should not have clicked there. Oh dear. That was stupid. This is the one that's pending. There we go, completed the level. Yay, okay. Thanks for watching.